Screening efficiency is how effectively a vibratory sieve separates particles by size. When optimized, it ensures correct particles pass through and oversized particles stay on top. Throughput remains consistent, but performance depends on several factors, including particle size, mesh selection, vibration settings, and moisture content. So what causes poor performance? One of the biggest issues is mesh blinding. This happens when particles get stuck in the mesh, reducing open area. This slows production. It's often caused by sticky or wet materials, fine particles close to mesh size, or material clumping together. Other common issues include incorrect mesh size, uneven material feed, and poor vibration setup. The good news? These problems can be solved. Start with self-cleaning systems, like bouncing balls, sliders, or ultrasonic cleaning. Next, ensure correct mesh selection based on your particle size distribution. You should also reduce moisture where possible, break up material clumps, and optimize vibration and feed rate. To increase throughput, use a larger screening area, maintain a controlled, even feed, and set the correct vibration amplitude. For advanced applications, multi-deck sieves can separate multiple sizes at once. Vibratory sieves are used across many industries, from food and pharmaceuticals to chemicals, plastics recycling, and metal powders. Anywhere particle separation matters, efficiency is critical. The key takeaway? Optimize your setup, choose the right mesh, and control your process, and you'll achieve consistent, high-efficiency screening. To learn more or to test your material, go to vibrating-sieves.co.uk. Like and subscribe.